Hello everybody, we're going to have a look at how we can move and manipulate some algebra around today, focusing on trigonometric functions and identities. Okay, so first of all, let's have a look at some nice simple examples. If I have 3 cosine theta plus 4 cosine theta, then of course this simplifies to 7 cosine theta. And if I have tan alpha minus 3 tan alpha, well, I've got minus 2 tan alpha. The usual rules of algebra still work here. The next thing, right, okay, we can remember some swaps from the previous video, okay, for this question. So what we need to recognize here is that sine of minus theta is exactly the same thing as minus sine theta. So we can make that direct swap. And from here, we can say, well, minus of something plus 2 of something is that original thing. So that is going to be sine of theta. In B, we've got another swap to perform. We should be able to spot that cosine of pi over 2 minus theta is identical to sine theta, and cosine of pi minus theta is identical to minus cosine of theta. So from there, again, we haven't finished. We need to recognize as well that sine theta over cosine theta is tan of theta. So we end up with minus tan theta as our final simplified expression. Okay, on to the next example. So 2 minus 2 sine squared theta. So first of all, both these terms have a 2 in them. So clearly we can take that out and rewrite it with some brackets in. But from there, we are supposed to spot that is equivalent, that bracket is equivalent to cosine squared theta, because of course, as explained in the previous video, 1 is cosine squared theta plus sine squared theta. So then moving that sine across, 1 minus sine squared theta is equal to cosine squared theta. I won't go through that in detail every time, but therefore we can make the swap that this is 2 cosine squared theta. Into the second part here, well, we can factorize this expression because both of the two terms have a sine theta in common. So we could rewrite part B as sine theta, open bracket, cosine squared theta plus sine squared theta. And we recognize again from that previous work that cosine squared theta plus sine squared theta is equal to 1. So this expression becomes just sine of theta. Okay, next example, we have to expand some brackets. So this is exactly as you would expect it. We've got to do cosine theta minus sine theta multiplied by cosine theta minus sine theta. I am a big fan of multiplying out using a multiplication grid. So let's write this out. Cosine theta and a minus sine theta multiplying by a cosine theta and a minus sine theta. So cosine theta multiplied by cosine theta is, of course, cosine squared theta. And minus sine theta multiplied by minus sine theta is going to be a positive sine squared theta too. We can see those two are going to end up equaling 1 when we add this up. We've also got a minus cosine theta sine theta here and a minus cosine theta sine theta here when those terms are multiplied together. So adding this up, we are going to have, well, the cosine squared theta plus sine squared theta, that is going to give us just a 1, right, from the original Pythagorean identity. And we have 2 of these. We have 2 lots of minus cosine theta sine theta. So if we collected them up, we'd have minus 2 cosine theta sine theta. There is our finalized simplified expression. Okay, so factorizing now. So we're going to factorize these examples exactly as we would factorize anything else. The first one we should be able to spot is the difference of 2 squares. So we can just square root both of these 2 terms with a plus and a minus in between them in the 2 brackets. And we can say we've got cosine alpha minus sine alpha multiplying by cosine alpha plus sine alpha. In part B, it's a quadratic expression. So, I mean, to help us to visualize this, perhaps you might want to say, well, okay, tan theta is equal to y. So this expression then becomes y squared minus 3y plus 2. Well, you have lots of experience in factorizing things like this. This is going to be y minus 2 and y minus 1, because those two numbers multiply to make positive 2 and they add to make a minus 3. Swap it back though for the tan. We must write our final answer as tan theta minus 2 and tan theta minus 1. There we go, we factorized. Next examples. Okay, so in these ones, well, we got to look for things to cancel. So straight away, we can take a factor of 2 out of the numerator of this first fraction. 2 bracket 1 minus cosine squared theta all over 1 plus cosine theta. Now at this point, you might want to swap that bracket for a sine squared theta, which would be allowed, but do you know what? There is a more appropriate move to make to simplify, and I know this because I can see that denominator. That denominator could be cancelled if we use the difference of two squares instead. So if we write this out again using the difference of two squares, so because both of the 1 and the cosine squared theta are square numbers, that is equivalent to 1 plus cosine theta, 1 minus cosine theta. And now we can now cancel the expression on the denominator. This is going to leave us with 2 lots of 1 minus cosine theta, and this is a simpler version than what we would have achieved if we had swapped out the bracket originally for the sine squared theta. Okay, in B, let's have a look and see if we can do this one in the same way. Again, it's the similar sort of thing. Watch out for the difference of two squares. We can keep the numerator the same and write cosine theta minus sine theta there again, but use the difference of two squares to write this out in factorized form. Cosine theta plus sine theta multiplying by cosine theta minus sine theta. Then we can cancel and we are left with 1 over cosine theta plus sine theta. Okay, you should be able to do these questions now. Good luck.